solving radical equations that require additional steps. These additional steps are things like getting square roots by themselves. So, given something like this, the square root is already by itself, so we can square both sides. So we get 16 minus x equals, squaring this side is the same thing as having two of them. So we're going to have to FOIL. You get x squared plus 4x plus 16. 16 minus x equals x squared plus 8x plus 16. Getting everything to the same side. I get 0 equals x squared plus 9x, because that also cancels. Factoring out an x, I get x plus 9. So x equals 0 and negative 9 as options. Well, then we want to check. So if I stick 0 in, I get square root of 16. Does that equal 0 plus 4? 4 does equal 4. 0 checks out. If I stick in negative 9, 16 minus negative 9, does that equal 9 plus 4? Square root of 25, does that equal negative 9 plus 4 is negative 5. 5, does that equal negative 5? No. So here's a case where with two solutions, one checks out, the other one doesn't. So our final solution is x equals 0. Given this problem, square root's already by itself, we can square both sides. So x squared minus 3x plus 18 equals, remember this is the same thing as writing two of them. So I get x squared plus 3x plus 9. Getting everything to the same side, subtract x squared, it goes away. So I get negative 3x plus 18 equals 6x plus 9 plus 3x minus 9 minus 9. So 9 equals 9x and x equals 1. Let's check that solution out. Square root of 1 squared minus 3 times 1 plus 18. Does that equal 1 plus 3? 1 minus 3 is negative 2, plus 18 is square root of 16. Does that equal 4? Yes, 4 does indeed equal 4, and that solution checks out. So this would be our solution of x equals 1. Doing one more problem. This one's a little more in depth. It kind of has an interesting turn in the middle. So say we're given a problem with two square roots, because the rest have had one, but this one has two. So the first thing you need to do is get one of them by themselves. So I'm going to leave 3x plus 1 on the left and add over the square root of x plus 4 square root. Then, just like as before, we square both sides. Square root of a squared cancels, leaving me with 3x plus 1. This is the same thing as saying square root of x plus 4 plus 1 times square root of x plus 4 plus 1. There's two of them. So when I times the first two together to FOIL, it drops the square root. When I times it to the second piece, I get square root of x plus 4. Inner is plus square root of x plus 4. And last is plus 1. So I get 3x plus 1 equals x plus 5 by combining those three, plus 2 square roots of x plus 4. Minus the x and minus the 5 to the other side. So I get 2x minus 4 equals 2 square roots of x plus 4. Dividing the whole equation, both sides by 2, I get x minus 2 equals square root of x plus 4. So now, taking this one step further, we have to go and square both sides again once we have that second square root by itself. So in other words, I have x minus 2 times x minus 2 equals x plus 4, because the square root and the squared cancel each other out. X squared minus 2x minus 2x plus 4. X squared minus 4x plus 4 equals x plus 4. Subtract the x and the 4, subtract the x and the 4. X squared minus 5x. Factor out an x, you get x minus 5. So you get two solutions of 0 and 5. Well, if we test them in the original function, so come back up, here's the original. So we would have, putting in a 0, you'd have square root of 1. Putting in a 0 here, you'd have minus square root of 4. That's 1 minus 2. That's equal to negative 1. That's not equal to positive 1. So when sticking in 0, that doesn't work. When I stick in 5, I have square root of 15 plus 1, or 16, minus square root of 5 plus 1, or 9. Square root of 16 is 4, square root of 9 is 3, that equals 1. Hey, that does equal 1. So, our final answer is x equals 5. The other one didn't check out, which is not uncommon, so you have to check your answers. So, let's quickly run through this one again, because this was a little bit complex. When given two square roots, first, get one by itself, square both sides. You're going to end up with a binomial to factor or FOIL on one of the sides. So it's going to still have square roots in it. Get that square root by itself. So we got the square root by itself and simplified everything to the other side. Now it's just like the problems if we had one square root. We have to square it again. So that's where this comes in. We squared it again, combined like terms, got all the x's to one side, solved for x, checked our two solutions. So if you have two square roots, you're going to end up doing the squared step twice.